Hello friends, subscribers and new viewers of this channel. In this video tutorial, we will introduce one very powerful large language model or LLM for image and video understanding. The name of this model is MiniCPM-V version 2.6. MiniCPM is a series of end-side multimodal large language models designed for visual language understanding. Visual language understanding is a fancy word for understanding images and videos. That is, you provide an image or a video to the model as well as a question or some instruction, and the large language model should understand what is in the video or image and provide you with an answer. Here's a test case that best illustrates the power of MiniCPM and the power of visual language understanding. We are providing two photos to our model. The first photo is over here and the second photo is over here. And we only ask the following question. Is the animal on the first photo a threat for animals in the second photo? Note over here that we are not providing any additional information about the type of the animal on the first photo and what are the animals on the second photo. That is, the algorithm and the model have to recognize the animal on the first photo and the animals on the second photo. And once they recognize them, they have to figure out, is the animal on the first photo a threat for animals in the second photo? In this video tutorial, you will learn how to download and install MiniCPM on your local computer, and furthermore, you will learn how to write this code that will implement the algorithm and that will ask the question and provide the answers. And here is a brief demonstration. Over here, we'll load the first image, that is the image of the coyote, and over here we'll load the second image, that is the image of geese. Then we ask here the question, is the animal on the first photo a threat for animals in the second photo? And over here, we ask the model and we print the answer. And let's see real-time demonstration of this algorithm. Over here, I will run this script. Notice that this script is run locally on my computer equipped with NVIDIA 3090 GPU with 24 VRAM memory. And then, literally after 15 seconds, you will get this answer. Based on the images provided, it is reasonable to consider whether the animal in the first image could pose a threat to the animals in the second image. Here are some points to consider. The animal in the first image appears to be coyote. Excellent. So the algorithm was able to recognize that the first image represents the coyote. Then, let's see the second image. In the second image, there are birds walking along the road near a body of the water. Excellent. So the algorithm was able to recognize that on the second image we have birds. And then, given these considerations, it is plausible that the coyote in the first image could be a threat to the birds seen in the second image. This is amazing. This is truly amazing. And you have some additional comments. In the sequel, we explain how to install MiniCPM in Linux Ubuntu. The installation instructions provided on the GitHub and Hugging Face websites might be incomplete, and we will have to do some tweaking to properly install MiniCPM locally. Also, we will have to modify installation instructions and demo Python files such that MiniCPM can work without issues on a local computer. Okay, so let's start. First of all, open a terminal, click here and search for terminal. Here it is. Okay. First, we have to run these two commands. Sudo apt update, enter your password, and be patient. This will take some time. Whenever you want to install something in Linux Ubuntu, you need to use this command. And then after that, you need to run sudo apt upgrade. And click on yes. Here you have to be patient. This will take some time, and over here you can see the progress. Next, we will have to make sure that we have Git version controlled program installed on our system. And we can install it by using a single command given over here. But just let's wait until this process completes. This will take some time. Then we need to run this command, sudo apt install git all. Then we have to make sure that we have git support for large-scale files, and we can do that, and that is we can install git support for large-scale files by first running this command. And you have to wait here, of course. Then you need to run this. And then you need to simply run git lfs install to initialize. And then we can continue. First of all, we need to create a base folder for our packages. To do that, first of all, go to the home folder, then create the codes folder. I already have it on my system, so I will not execute this command. However, you have to execute, then type cd codes to go to the codes folder, and over here we need to clone the remote repository from GitHub. So let me first just copy this, open my web browser and make sure that this is correct over here. Here it is. This is the correct GitHub page, and we need to clone this repository over here. However, this is not complete. We will still have to clone the models by ourselves, and we will do it manually. So let's first execute this command. Let me go here and clone this remote repository. So be patient over here, since this will take some time. Then let's make sure that the downloaded folder exists. Here it is. And we can safely navigate to this folder. And over here we should get the exact copy of everything that's online. That is, this thing should be a copy of this repository. Okay, so let's continue. The next step is to create our Python virtual environment. It's always a good practice when you install a package or a program in Linux Ubuntu and you want to run it to create a Python virtual environment. We do it like this in Linux Ubuntu. Then I need to activate my virtual environment. I will do it like this. And you can see that now my virtual environment is activated. Okay. Next, we need to start installing the necessary libraries. First of all, whenever you want to install something, make sure that you have setup tools. So first run this. And you can see that the requirement is already satisfied, and you can type pip list to see the list of all the packages, and you can see that we already have setup tools. However, just in case, run this to make sure that this is the case. Then, if you now type this thing, you will see over here that there is this requirements file that specifies all the libraries that are necessary to run this code. So let's see for a second what are the requirements. Packaging, addict, added distance, and you can see it over here. Right, some of these things are commented, and however, they are necessary for running the code. Now, these requirements are actually incomplete. However, let's first run this, and this code line will actually install all the packages specified in the requirements file. So let's run this and be patient over here. This will take some time. Over here you are going to install CUDA, you're going to install PyTorch, NumPy, and bunch of libraries necessary to run this code. After some time the process is completed, and over here you can see a list of installed packages. However, if you try now to run the code, you will not be able to run it. There still will be some missing packages. So let's install these missing packages. I figure out this by trial and error that we will first need this thing. That is the Hugging Face hub. Then we will need Veal. And if you don't install Veal as well as this flash attention, the code will not run. Okay, now the next step is actually to do a few checks. First of all, you can go to the official Hugging Face website of this model, and if you scroll down all the way, you will find some demo files over here. Here they are. Now, if you just try to run these demo files on your local computer, there will be an issue. What will be the issue? These demo files will actually try to download the model from the Hugging Face website. That is, when we actually cloned this GitHub page, we didn't actually download the models. So what these demo files will try to do, they will go to the Hugging Face website and they will try to download these files over here. You can see 1, 2, 3, 4 huge files. So it's around maybe 10 gigabyte of models. Instead of doing that, we will actually manually download these files and this complete Hugging Face repository. So let's learn how to do that. First of all, let's go back to the terminal. And first of all, we have to make sure that we are in this base folder. So consequently, let's go again to this base folder. Then in this base folder, you need to create another folder. I will call it model files. And we are going to store all the model files inside of this folder. Then let's navigate to this folder by executing this. And let's check the path in this folder by typing this. And you can see the complete path. Now, copy this path and store it over here. That is, save it somewhere else since we will need this path. The next step is actually to create a download script. Consequently, go back one step, and over here you need to use your favorite Python editor to create the download script. I will use VS Code. I actually created a video tutorial explaining how to install VS Code in Ubuntu Linux. So click on File, and link to that tutorial will be provided in the description below. Okay, so click on File, and let's call this script download.py script. Let's save this script, and over here I simply need to insert this. Let me now go to VS Code and paste. Okay, so let me now just correct one thing over here. This should be actually a function. Yes, it's good. So what's happening over here? Over here from Hugging Face Hub, we import this function snapshot download. This function snapshot download will actually download the most recent version of the model. To call this function, we need to write the function name, and then we need to write the repository ID. To find the repository ID, go to the website, to the model website, copy this, then go over here and simply paste it. Okay, then we need to specify the local directory for downloading the file. This will be actually the directory specified over here. That is, go back and find the path that you found. You need to put the absolute path of the model files folder and paste it here and save. Now you can execute this code. To execute this code in VS Code, press and hold Ctrl Shift and P. Over here, search for Python, select Interpreter, click here, and make sure that you select Python executable from our virtual environment. Click here and run this. Now this script will actually download all the files from this repository. That is, it will create a complete copy of this repository on the Hugging Face website. After approximately 5 minutes, the process will be completed, and let's verify that all the model files are downloaded. So go back to the terminal, type this, and let's see where is our model. Let's go to this folder model files by typing cd model files, and let's see the structure. Here are all the files, and we can see these huge files over here, and we can verify that they're also downloaded. Perfect. Let's continue. Let's go back to the base folder, and over here we need to create another folder. we need to create a folder that will store our video and image files. So let's run this command to create a folder for video files. And in this folder, you need to copy your image and video files. For this video tutorial, I actually prepared two images. This is the first one, and this is the second image. And I will provide these images together with the manual. Okay, so I will simply copy them. Then I will go to Home. Then I will go to Codes. Let me just find it. Here it is. Then I will go here, and then I will copy these files in my video files folder. Good. Let's continue. Now let's write our first test file. Click here on File, click on New File, and I will call the file test MiniCPM. And don't forget to put the extension Py. Okay, and I will save it in my base folder. And over here, to make this video tutorial as brief as possible, I will simply paste the content of the file, and I will explain every single line of this file. The purpose of our first test code that you can see over here is to see, can we recognize an object or an animal from a given image. That is, we will provide an image to the model and we will ask the model a question. For example, in my case, I will provide an image of this coyote and I will ask the model what is the animal on this photo. And the model should be able to recognize the animal. So this is the first test. I created this file by actually using a demo Python file provided on the Hugging Face website. However, I significantly modified this file such that it performs the task that I wanted to perform. Okay, so over here we need to insert the path of our saved model. So how to do that? Well, the best strategy again is to go to the terminal. Let's see our model files folder. Here it is. Actually, here it is. So let's navigate to the model files. And let's make sure that this is actually the folder with all the models. Here it is. And the best strategy is simply to type pwd and you will get this absolute path. So copy this absolute path and simply put it here. Okay, then I need to do the same thing over here. Then I need to save this and I will start explaining the code. First of all, we need to import Torch. This is PyTorch. Then from PIL, we need to import image. This is the pillow image library. Then from transformers, we need to import automodel and autotokenizer. Then over here we set the manual C to 0 such that we always have the reproducible results. Over here we need to load the model. Okay, so what do? We call automodel dot from pre-trained, since we want to load pre-trained parameters or weights, and over here we specify the path of the model, and that's exactly the path of the folder that I just shown. And over here we need to specify trust remote code true. Then we need to specify this parameter attention implementation as the PDA, and over here we need to specify the data type for PyTorch. That's it. Then we need to create a tokenizer, so we called autotokenizer from pre-trained, and we load the model again from this folder whose path I just retrieved, and we specify trust remote code true. That's it. Okay, the next step is actually to load our image. Over here again we need to go to the terminal, so let's go one step back and let's see where are the files, actually where is the folder with images. Here it is. It is in video files. Now over here I will specify a relative path here. Okay, then I will go to that folder. Let's go to the video files, and over here I'm simply going to use coyote file. So I will simply copy this and put it here. Over this dot over here represents actually the path of the current base folder. That is this path over here, from here to here. Or you can do something else. You can simply specify the absolute path to this file over here. It depends what you want to do. However, I'm going to do it like this. Now, it's very important that we are actually executing this file, test MiniCPM, from the base folder. And you can see over here that the base folder is active. Otherwise, you will have to make the absolute path. Now we are going to ask a question. What is the animal on the photo? Simple as that. Then we are going to formulate the message structure. Our role is user, our content is image and question, and image is loaded over here. Keep in mind that. That's it. Then we call the model, we call the chat, and we ask this thing. Image we specify first of none, tokenizer, and we print the answer. That's it. Over here we specified image to none, however the image is still provided as a message. If you analyze this data structure, you will see that the image is actually provided. This model.chat will generate the answer, then over here I will print 2 empty lines, and then I will print the answer. And we can do further. We can do the second round chat. Then we can ask the following. We can append the message, again as an assistant, and we can specify the content. It will be the content provided by model.chat, and then we can do further. We can, for example, ask an additional question, or we can ask for some clarification. Over here I just say an additional word, introduce something about coyotes. That is, explain what are the coyotes. However, the purpose of this code is actually to recognize the coyote. Okay, so let's continue, and then again we call model.chat, image done, messages, tokenizer is equal to tokenizer, and we print the answer. And what do I do over here? I save the answer in a text file such that you can use it in some other program. I simply add answer 1 and answer 2, and I save them in the file. Simple as that. Okay, so let's run this code. Again, to run this code, make sure that interpreter is selected properly. Press and hold Ctrl-Shift-P. Then over here, click on Python select interpreter. Make sure that this interpreter is selected, and let's run this. Let's see what will happen. Now here, the model is being loaded. The image will be loaded, and let's see what will happen. And voila, here it is. The animal in the photo is a coyote. Coyotes are medium-sized canids native to North America, etc. Perfect. And here is the second part of the answer. That is the answer 2. Coyotes are one of the most adaptable wild canids in North America. Perfect. This is what we want to see. So the code is working. Next, let's run our second test code. Click on File, New File, and I will code this code test2.py. So let's save it in the base folder, and over here to save time I will simply paste the code. Here it is. So what is the purpose of this code? The purpose of this code is to test reasoning, where the reasoning should be performed by giving 2 images. So what we will do over here, we will provide the image of the coyote. This will be our first image, then the image of geese, and we will ask the following question. Is an animal on this photo a threat to animals on the second photo? However, over here we will not specify if this is a coyote or a wolf or a dog or any animal, and over here we are not going to specify what type of animal is on the second photo. That is, the algorithm and the model should be able to recognize the animal on the first image and the animals on the second image, and then they will have to reason. Okay, so let's do that. Over here is the code, and again I need to do a few adjustments. But before I do these adjustments, let me explain a few things. First of all, we need to import PyTorch. Then from PIL we need to import the image, then from transformers we need to import auto model and auto tokenizer, and over here we need to specify the path to our model. Again, I'm going to use this path from the previous code since I already retrieved that path. Here it is. So over here we will load the model from pre-trained, and don't forget to put trust remote code true. Then attention implementation is SDPA, torch data type is torch float 16. Then over here we evaluate model and we specify that we want to use CUDA. Then we need to load the tokenizer. We load the tokenizer from pre-trained. Over here we need to specify the path. Here it is. To the model file and trust remote code true. Then we need to insert, or better to say, to load our images. Again, I'm going to use this path. Here it is. This is the path to my Coyote. Image, and let's find the name of the geese image. So if you go now to video files, you'll see that the name of the file with the geese is given over here. So consequently you need to do a few adjustments. Let me paste this. Over here I will have the relative path. And over here I need to specify the name of the file. Geese. Let me now do this. And here it is. And then over here we ask the question, is the animal on the first image a threat for animals in the second image? And we formulate our message structure. Role is the user, content will be image 1, image 2 in our question, and over here we call model chat, we specify the messages, we specify the tokenizer, and we generate the answer, and we simply print the answer. Over here I will not save the answer in a separate file, however you can do the same trick as I did over here. Okay, so let's run this code, make sure that the proper interpreter is selected, and then let's run this code. And this is the real-time execution. The models are being loaded, and let's see. This is real-time. Yes, you can see, yes, the animal on the first image could potentially be a threat to the animals in the second one. The animal in the first image appears to be coyote, which is known for its predatory behavior and can pose a risk to smaller animals such as birds and setter. And you didn't see over here, you can see that basically you'll get an answer. It's possible that the geese and other birds in the second image could be at risk from this coyote. So the code is able to recognize the animal on the first image, the animal on the second image, and it's able to reason. Perfect. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.